You're sitting in algebra, looking at an equation, and your brain just shorts out. -3 times -4 equals +12. If you lose money twice, common sense says you should be worse off, not suddenly richer. This confusion is a historical constant. Many of the most influential mathematicians who ever lived dismissed negative numbers as false and absurd. In the 16th century, François Viet argued that negative numbers were a logical impossibility and insisted they be discarded from mathematics entirely. These thinkers reached a deadlock because our physical intuition is often a poor guide for abstract rules. Human brains evolved to track concrete, physical quantities. We are biologically wired to count apples in a basket or points in a game. Negative numbers are human-made abstractions. You cannot see, touch, or hold a -3. Since our physical senses can't help us here, we have to use different logical frameworks to see why this rule is a mathematical necessity. The first rung of logic relies on a concept we use every day: debt. Suppose you have 3 separate $20 debts. On your balance sheet, that is 3 times -20, leaving you $60 in the red. Now, imagine a bank decides to intervene and subtracts those 3 debts from your account. By taking away your debt, the bank has made you $60 richer. A negative action applied to a negative state creates a positive financial gain. We can find this same logic within the physical laws of velocity and time. Think of a car driving backward at a steady pace. In physics, that backward motion is a negative velocity. If we film this in real time, the car moves away from its destination. But if we run the footage backward, we are applying negative time to that negative velocity. On the screen, the car now appears to move forward. This visual result shows how negative velocity and negative time produce a positive displacement. Moving away from the physical world, we can look at the internal logic of numerical patterns. 2 times 2 is 4. 2 times 1 is 2. 2 times 0 is 0. The pattern is consistent. Every time the multiplier decreases by 1, the result drops by 2. Following that rule into negative territory, 2 times -1 must be -2. Now we keep the -3 constant and change the first number. 2 times -3 is -6. 1 times -3 is -3. Here, each step increases the result by 3. What happens when we drop the first number to -1? To maintain the pattern, the result must increase by 3 again. The sequence itself forces -1 times -3 to equal +3. The final proof comes from the basic rules of algebra. We start with the fact that any number multiplied by 0 equals 0. We can replace that 0 with 2 numbers that cancel each other out, like 5 and -5. Using the distributive property, the -4 must multiply against every value inside those parentheses. We know -4 times 5 is -20. That leaves us with a simple balance. -20 plus our unknown result must equal 0. That unknown result must be +20. If negative times negative produced anything else, this entire system of logic would contradict itself and break. This rule isn't an arbitrary convention designed to make algebra difficult. It is a result we find repeatedly in the mechanics of debt, the geometry of motion, and the requirements of algebra. These patterns remain the same whether or not they align with our physical expectations. Moving beyond physical counting allows our brains to process abstract concepts that exist only in the realm of logic. Embracing these rules allows us to model a reality that our senses alone could never perceive. This weird math is the mechanism we use to find order in the patterns that govern the universe.